Good morning, students. Today we will discuss about the electrode potential. Electrode potential means a tendency of any electrode to lose or gain electron when it is placed in the solution of its salt. For example, it is a beaker, and in this beaker salt of copper sulfate is dissolved. Now copper sulfate will break into copper 2 positive and SO4 2 negative, copper ion and sulfate ion. These will be present in the solution, and place one rod of copper rod is placed in the salt of its metal. Copper rod in copper sulfate. If it's zinc rod, then zinc sulfate. If it's a silver rod, then silver nitrate solution. Now this rod can either lose or gain electron, either lose electron, donate, or can take electron, and this phenomena of either losing or gaining electron is known as electrode potential. We know gain of electron is known as reduction. Reduction is gain of electrons. That's why if this electrode or this rod takes electron from the solution, this potential is known as reduction potential. And if the rod loses electron in the solution, then that potential is known as oxidation potential. Oxidation potential means tendency to lose electron, and reduction potential is tendency to gain electron. This rod will lose or gain electron. It will depend on the concentration of the solution. It depends on the concentration of the solution, and we'll discuss about this in the next coming topics, where we will even find the reduction potential or oxidation potential by the use of a formula. Means with the help of numerical we'll find the value of the oxidation as well as reduction potential also. So this is the reduction potential. Now yesterday we did electrochemical cell. Here anode half cell, it is cathode half cell, and salt bridge. Now it is half cell. Here oxidation take place, anode half cell. Reduction was taking place here, it was cathode half cell, or it is known as reduction half cell, it is known as oxidation half cell. Now if we have to find the electrode potential of any of one half cell, then for that we have to use an instrument that is called as SHE, standard hydrogen electrode. Standard hydrogen electrode is used to find the oxidation potential or reduction potential of the half cell. For example, this is the diagram of SHE. This topic was in +1 also, and we have done in the class also, but again we'll revise it. What happens in this? One beaker or vessel is taken. In this 1 molar HCl solution is taken. 1 molar HCl solution, it means it will break into H positive and Cl negative, and a platinum rod is taken, and with that platinum rod a platinum foil is attached, and then it is covered by this, and from here it is a platinum wire. Okay, it is attached, and from here this point we pass H2 gas at 1 atmosphere pressure. H2 gas at one atmospheric pressure. Now what happens? It is known as standard hydrogen electrode, and we know the reduction potential of hydrogen is 0. The reduction potential means oxidation potential or reduction potential. It is 0 for the hydrogen. That's why the potential of the She is 0. The potential of She is 0. We have discussed in the first video of this chapter also, that the potential of the hydrogen is 0. It depends upon the other element. If its reduction potential is higher, means if I will say HF, we know the tendency of fluorine to gain electron is high. It means fluorine will get reduced. Means the reduction potential of fluorine is high. And if H2, its reduction potential was 0, but when fluorine attach with it, because its reduction potential is high, that's why hydrogen will show oxidation potential. And in the same way, if it is NaH, it is a metal, its tendency is higher to lose electron, that's why it will show high oxidation potential. That's why in this case hydrogen will show reduction potential. And we have also discussed that we never use the word oxidation or reduction potential separately. We use a term standard reduction potential. It means if H value is 1.10, it means its reduction potential is 1.10. But if its value is H is minus 0.80, it means its reduction potential is negative. It means in this case it is showing oxidation, and in this case, because the value is positive, hydrogen is showing reduction. Means the element which is attached with hydrogen in this case will get oxidized, and because hydrogen is being oxidized here, the other element will get reduced. Okay, so by using these things we can calculate even the electrode potential of any metal. But how the She works, means in which case it will show oxidation and in which case it will show reduction. It has HCl. HCl produces H positive ion. Now if the metal, if means you joined this She with any electrode, like I am making any electrode here, half cell. We don't know if it is reduction half or oxidation half. You connect it with the She and then see what is the change. Means in this solution two things are there. One will be H positive ion concentration and one is H2, because H2 गैस यहाँ से आएगी तो इसके अंदर H2 गैस भी होगी और इसमें H पॉजिटिव आयन भी होंगे, क्योंकि 1 मोलर है तो 1 मोल H पॉजिटिव आयन के कंसंट्रेशन होंगे. अब हम इसको जोड़ देंगे इससे, एंड देन विल नोटिस आउट ऑफ द H पॉजिटिव एंड H2 किसका अमाउंट इंक्रीज या डिक्रीज़ हुआ है, एंड बाय दैट वी कैन कैलकुलेट कि जो अदर एलिमेंट है उसकी ऑक्सीडेशन हो रही है रिडक्शन. वो कैसे? अगर H पॉजिटिव कम हो रहा है, H पॉजिटिव कैसे कम होगा? इलेक्ट्रॉन लेकर क्या बन जाएगा ये H, एंड दैट H विल चेंज इनटू H2 बाय द सेकेंडरी चेंज. इट मीन्स अगर H पॉजिटिव की कंसंट्रेशन कम हो रही है और H2 की कंसंट्रेशन बढ़ रही है, इसका मतलब क्या हुई? रिडक्शन, बिकॉज ये इलेक्ट्रॉन लेकर के H2 बनेगा. इन दिस केस यहाँ बीच में एक इंस्ट्रूमेंट लगा होगा जिससे पोटेंशियल मिलेगा आपको. पोटेंशियल की वैल्यू मिलेगी, वो नेगेटिव पॉजिटिव में नहीं होगी. मान लीजिए वैल्यू है 1.10, ये वैल्यू आ गई. अब ये 1.10 ऑक्सीडेशन है या रिडक्शन है वो पता लगेगा इस चीज़ को देख करके. आपका H की अमाउंट कम हो रहा है या H2 का अमाउंट कम हो रहा है. अगर H पॉजिटिव का अमाउंट कम हुआ, इट मीन्स उसने इलेक्ट्रॉन लिए हैं, इसकी क्या हुई रिडक्शन. इफ वैल्यू इज 1.10 इट विल बी रिडक्शन पोटेंशियल, द वैल्यू विल बी 1.10. बट अगर इसके H2 it will break into H2 will it will lose electron by changing into H positive and will lose 2 electron. Now if your she is losing electron, then the amount of H positive will increase, and if again this device is showing voltmeter, it is showing potentiometer, sorry, if this potentiometer is showing the value 1.10 but the amount of the H positive is increasing, it means H2 has changed into H positive and it shows that it is showing oxidation potential, then the value will be minus 1.10. We'll take it minus 1.10. And actually it was just to make you understand, just you should what information is necessary for you, that what is she, its structure, and how it shows oxidation and reduction reaction. H2 will change into H positive and lose electron, it is showing oxidation, that's why in this case she will act like anode, and in this case H positive is taking electron changing into H2, it means here she is acting like a cathode. Okay, and one more thing here is EMF, or EMF is known as electromotive force. Means electron, the force required for the movement of electron. EMF, the force by which the electrons move in a cell. Now how will you calculate the EMF of a cell? For example, the formula is EMF E cathode minus E anode. E cathode minus E anode, it is the formula of EMF. And in here it is given also one question NCERT, how would you determine the standard electrode potential? Standard electrode means reduction ही, स्टैंडर्ड इलेक्ट्रोड का मतलब रिडक्शन ही होता है. हाउ वुड यू डिटरमाइन स्टैंडर्ड इलेक्ट्रोड पोटेंशियल ऑफ द सिस्टम Mg to Mg positive? Now what you will write, we know the value of EMF is calculated by the using formula E cathode minus E anode, and you have to use what? She. You have to use she to find the standard electrode potential. Because standard means the electrode potential which has been derived or calculated by the use of she. SHE. If you are using the she to calculate the oxidation potential or reduction potential, then in that case that oxidation or reduction potential is known as standard electrode potential. It is given here also. What is standard oxidation potential? Oxidation value of electrode when it is connected with she. So by the use of she, if you are calculating the electrode potential, then it becomes standard. Now you know that electrode potential of H is 0, and now Mg to Mg positive, you have to Mg2 positive, you have to be alert and see it carefully. What's happening here? Mg से क्या बन रहा है? Mg2 पॉजिटिव. ये हमने +1 में भी कहा था, बड़ा आराम से पता लगा लोगे आप. अगर ऑक्सीडेशन की वैल्यू इंक्रीज़ हो रही है, यहाँ पर Mg की वैल्यू तो 0, यहाँ कितनी हो गई? 2 पॉजिटिव. इंक्रीज़ इन ऑक्सीडेशन का मतलब यहाँ क्या हो रही है? ऑक्सीडेशन. इंक्रीज़ इन ऑक्सीडेशन नंबर मीन्स ऑक्सीडेशन हो रही है, और वैसे भी शो कर रहा है यहाँ कि ये 2 पॉजिटिव का मतलब इलेक्ट्रॉन लूज किए हैं. तो Mg ने इलेक्ट्रॉन लूज किए, ये क्या शो कर रहा है? रिडक्शन पोटेंशियल. इट इज़ शोइंग रिडक्शन पोटेंशियल. अगर ये रिडक्शन पोटेंशियल शो कर रहा है तो रिडक्शन किसकी होती है? कैथोड की. रेड कैट रिडक्शन अकरिंग एट कैथोड. It means EMF of Mg to Mg2 positive when it is connected with hydrogen. Mg to Mg positive is E cathode, that's why यहाँ पर इसकी क्या हो रही है ऑक्सीडेशन, तो ये क्या होगा आपका ई कैथोड, यानी कि आपका हाइड्रोजन यहाँ पे कैसे काम करेगा एज ए कैथोड Mg, बिकॉज हाइड्रोजन इज टेकिंग इलेक्ट्रॉन एंड कैथोड पर क्या होगी रिडक्शन, H जो है शी जो है इलेक्ट्रॉन लेगा, इट्स वैल्यू विल बी 0 माइनस ई एनोड। ई एनोड क्या होगा यहाँ पर Mg2 positive value, Mg2 positive value is E negative, that's why EMF will be equal to minus E एनोड। जो एनोड की वैल्यू होगी उसको आप माइनस कर दोगे, वो EMF आ जाएगा Mg2 पॉजिटिव। ओके, सो in the next video we will discuss about the numericals of the nonst equation.